Hi everyone, welcome to today's lesson. Today we want to explore a concept in differentiation known as implicit differentiation. You know, whenever you are given an explicit function, that is y being a function of x, it is much easier to differentiate using the general rule or even using first principles. But if I give you an implicit function like f of xy equals 0, something that looks like this, x squared plus y squared equals 0, you may want to write y in terms of x, but that will lead you to two different equations because of the square root sign, right? And then it becomes a bit messy when you are doing the normal differentiation. So there is a way to differentiate implicit functions like these ones, and that is what we are going to look at. Now let's pick a first example, which is a simple one I've written here. We want to differentiate x squared plus y squared equals 0. Now, how do we do that? You differentiate each term separately, which means I'm going to differentiate x squared separately and then differentiate y squared separately. But you need to take note of something. Anytime you differentiate a term with y, like this y squared, you need to attach dy dx to it, right? Because it's an implicit function, right? It means that y is a function of x, but it is embedded in it. So you don't see it directly. So it's some sort of indirect y being a function of x. So anytime you differentiate a term with y, you need to attach dy dx to it. So I'm going to differentiate x squared to get 2x plus, if I differentiate y squared, I'll get 2y. But because it is a y term, I'm going to attach dy dx. And if you differentiate 0, that is just 0. Now I am looking for dy dx, so any other thing that does not have dy dx, I move it to the other side. So I'm going to have 2y dy dx, that is equal to minus 2x. Since I'm looking for dy dx, I divide here by 2y, divide here by 2y, and then finally I have dy dx equals minus x over y, because the 2's will cancel. So if I differentiate, if I take the implicit differentiation of the curve x squared plus y squared equals 0, I get minus x on y. Alright, let's look at an example 2. Let me look for a more complex example for us to do. So we have 3xy plus sine y minus e to the power y plus x squared equals 0. Don't be scared. Let's take this example. So just as I said, you are going to differentiate each term separately, but take note that anytime you differentiate a term with y, you need to attach dy dx to it. So I'm going to start with this one, but here you need to be careful. We have product of two functions, that is x and y, so we are going to employ what we call the product rule, right? So I'm going to keep the x and then differentiate the y, which is 1, and I will attach dy dx. Let me put it in bracket, plus I'm going to keep the y and then differentiate the x, which is just 1. Alright, plus, now anytime you differentiate the sine function, you get cos. So sine y, if I differentiate sine y, I'll get cos of y minus, now e to the power y is the exponential function. So if I differentiate e to the power y, I'm still going to get e to the power y, but since it has a y term, we are going to have dy dx plus 2x, and that is equal to, let me put it here, 0. So we differentiate each term separately. Then let me expand this bracket. So I'm going to have 3x dy dx plus 3y plus cos y minus e to the power y dy dx plus 2x equals 0. Now my aim is to solve for dy dx. So any other term without dy dx, I will move it to the other side. So I'm going to keep 3x dy dx minus e to the power y dy dx. Then I'll move the rest to the other side. So I'm going to have minus 3y and then minus cos y minus 2x. Here I'm going to factor out dy dx, and I will be left with 3x minus e to the power y, and then here today is going to be negative out 3y plus cos y plus 2x. since I'm looking for the y dx, I'm going to divide through by 3x minus e to the power y. I'll divide here too by 3x minus e to the power y. This is just going to cancel that, and then finally we are going to have the y dx equals minus 3y plus cos y plus 2x. Don't forget, I've just factored the negative out, all over 3x minus e to the power y. And so this is the derivative of the function we have. All right, I hope you enjoyed the lessons. And let me give you some examples to try, maybe just one. Try one example and then put it in the comment section. So I need you to differentiate this function, that is x squared plus xy minus ln natural log of y equals 3. Try this one and then put your answers in the comment section, or you can still send it to my email. Thank you very much.